Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they're working on. Today we have Jove. Hi Jove, tell us a few words about yourself and about the tool you want to show us.
Hi, let's say. So my name is Zhong. I'm a co-founder of Timeplus, a startup company based in US, but myself is based in Vancouver, Canada, but we have engineers in different places of the world. So Timeplus is a streaming first analytics company. We focusing on providing a unified and a streamlined analytics platform for developers, for data engineers. And recently, actually 3 months ago, we open sourced our core engine under Apache License 2. So this Timeplus Proton is something I'm going to demonstrate. And hopefully you see the value and more people will share the idea, give our feedback, and help us to build a better engine together.
Yeah, thanks for making it open source.
Yeah, I mean, we actually, there's a lot of reasons I can share a little bit later, but we're very excited that is we moved from more like cloud services to have this open source engine so that we can make this more accessible to all the developers.
Yeah, that's quite interesting. So I really want to see the demo.
Okay, cool. So before I share the screen, I guess many people read the book called the Think Fast and Slow. And in that book, they introduced the concept of system 1 and system 2 of the brain. Essentially, system 1 is part of the brain that is you can absorb the latest information easily. For example, like when someone hits you, when there's some obvious signals, you react to it without thinking too much. Right? That's the think fast part, the system 1. The system 2 is more about more analytical. You get a lot of knowledge. You think that slowly but carefully. But as a human being, it's very common to combine the system 1, system 2 together. But actually, I've been in this data space for a long time. I think many of us focus a lot on the system 2. For example, the databases, data warehouse, data lake. Those are more like system 2 because you gain a lot of data, or we call big data, right? The big data give us a good foundation for decision making. But recently, with the rise of, for example, Apache Kafka, Apache Flink, Pulsar, so we started to focus more about this data in motion and absorb what's the data from, for example, from IoT, from all the sensors, or even the changes from databases, so we can provide a much timely reaction to it. So this is started to build some real-time analytics or streaming analytics. But even today, we have a different variation. For example, you may know the architecture of Lambda or Kappa. So there's some attempt to provide both core like system 1, system 2 together. But reality that is, in many cases, you have to build a system with a lot of components, a lot of even using different language with different microservices, put them together. So one of the vision of Timeplus that is we want to provide a unified engine, analytics engine, that just like your forebrain, you have both system 1, system 2. You don't have to have set up 2 systems. You don't have to ask multiple people. You can make decisions based on A is the real-time data, B is the historical data. For example, you can use SQL to query both historical and the real-time part. So that's the context of what we're building. That is, we focus a lot on the unification, not solely as a OLAP database or solely as a streaming processor. You may call us as a streaming OLAP or just like think fast, think slow, think Proton. Okay, so let me share my screen.
Very nice analogy. I liked it. I read the book. It was like more than 10 years ago, but I still remember the system 1 and system 2.
Yeah, I think that book was from 2011. But yeah, I mean, it's a very good book, and
like it's very large. It's a very big book. Yes. Like there's a lot of material.
Okay, cool. All right, so so this is our GitHub repository on the Timeplus.io/Proton. Again, like many other companies, we start from the IO, but eventually we get the Timeplus domain. But you can just go to this project to learn more details. But I'm not going to go over this into this. Let's jump into the demo, shall we? Okay. So what I do is let me show you how we query the real-time data and how we query the historical data. I have set up a Docker compose. So I set up a Docker compose for our data talks expo episode today. So it's because I'm going to demo a lot of stuff. So there are multiple components, but
and this Docker compose is already in the repo, right? Where do you find it?
Yeah, in the repo. Go to this one. So in the Proton repo, you can go to the examples. So we have lots of examples like this awesome sensor log. I'm going to demo how to visualize the sensor for your phone as a chart. Car sharing, CDC, all those stuff. So I just temporarily create a new folder to combine everything together, but you can get each separately. So go back to the compose file. So I'm using car sharing event generator just to keep pushing data to Proton. And Proton will provide both single binary for Linux for Mac, or you can just use as part of the Docker or Kubernetes. So and we can open multiple ports. So it's very easy to get started with Proton. So I think it's already started. So let me connect to it. And so everything in Proton is stream. So similar to table to most databases. So what we are going to show demo is using the car lab data. So the interesting thing that is if you select from car lab data, so as you can see that is we just run a simple select star from the string name or table name. And you can see that is we actually, this is a round robin query, or we call streaming query. So the idea that is every second that data generator container is able to send data to the Proton, simulating, for example, you might have multiple cars on the street. The car, what's the current speed, whether they are stopped. For example, even you have certain revenue generation, how much revenue you generate every second, every minute. So you can see that is this select star. It processes about 300 rows every second, and we show all the results. So this is a streaming query. But in the same time, if you wanted to check how many events in the past, you just do count. And you put a special function called table. Now, as you can see, that is we have if I run this over time, you see different results. So this is we call system 2, right? The historical part. You can easily process data in the past, or you can process data in the current in the real time. And you can even do some aggregations. For example, like I don't want to check all the current results. I want to see from now on how many events I get from the sensor. You can see I start get 200, then 10,000. So this is looking forward how many events I get. So
it's total number of events, right? Or it's
yeah. It's like from this query is started, the number of events I accumulated. Yeah. So you can do all the regular aggregations, even like P99. So by leveraging both this historical data processing and the real-time processing, you can have a better chance to, for example, figure out, hey, for example, at this point, in which area your car doesn't meet the demand. For example, you are running something like Uber. right? So you might want to add more cars, or you might update your pricing strategy. And also, because we also access to the full historical data, you can also have a single query to determine, based on the historical patterns, what's the outline. I'll give you the other example. That is, for example, if you are having a system to track where the person log in. Like, for example, usually the person logging from Pittsburgh, and suddenly the person logging from New York. And we can have a single query to figure out, hey, this is the latest login event, but this is the common login city for the past, say, half year. And this is not in the list, then we can trigger alert. But by combining this system 1, system 2, as I said, this is really give you opportunity to simplify a lot of things and provide the right action based on both the new data and the old data. So this is a quick demo, but what is more interesting, that is, for example, right now we already have this car level data. I think I have a dashboard somewhere. So this is Grafana. We support multiple systems such as Grafana or Metabase. For example, this is the dashboard. So Grafana actually provides real-time charting. So not many VI systems support that. So you can see that is there's no refresh button on this dashboard, right? And but you can see this is the current average location, and this is the car all the car data, and you can see there's a nice movement where the car is moving, what's the current average speed. And if you check the query, for example, this one is as simple as this select average speed from the string. And if I check the other one,
this query works in the same way as the count query you showed, right? So this is the average speed from the time the query is executed till now.
Yes. We can even support like you can go back to a certain time. So I don't want to accumulate data from now. I want to starting from the beginning of the day or beginning of this month. So
let's say if I want to have average over the last 5 minutes.
Oh, yes. So
some sort of like window sliding.
Yeah. You have good understanding about that. So for example, in that case, again, this is a live demo. I'm not sure there are any issues, but so in the streaming world, there's some idea regarding different window functions. Right? For example, Tumble is a function for you to have fixed window. Say you want to say every 5 seconds, so that we can see the data more timely. And you need to group by, say, window start.
I think this is what you would have with Prometheus, right?
Yes, you can run aggregations. And so Tumble, and so let me, yeah, the window is relatively small.
Seems to work.
Yeah. So it works. So Tumble is the like fixed window, but you can also have hopping windows, session windows, things like that. So we provide a very rich streaming processing capability. Some of your audience may know things like Flink. Actually, our streaming capability is very similar to Flink, but there's no JVM, there's no GC, so just C++. And also we provide our historical data. So our historical part is actually based on ClickHouse, but you don't really see the ClickHouse as a Docker image or a process. So actually, it's part of our code base, and we made some enhancement so that it can speak to the streaming in the same message format, and also we enhance a lot of capability. But if you already using, say, ClickHouse, so you almost ready to use Proton, because if you just use Proton as the OLAP part, it's just as good as ClickHouse. But beyond that, we provide real-time data injection, streaming processing, and many other nice features. Okay,
And
so
when it comes to this demo, I'm just curious what is exactly there. So as I understood, I saw from your Docker Compose, so there is Red Panda, which is like, I think similar to Kafka, right? So which probably where you push the events, right? And then what you do is you ingest events from this stream. And
not exactly. So the reason why you saw Red Panda is because for the other demo. So if you go to example/car sharing, it is as simple as two container, the Proton and the car sharing event gen. So that's no Kafka or Red Panda in between. The reason that is we actually have more like a streaming storage or WAL, or rather high log in our system. So something like Kafka, but it's not that general purpose. So how things work, that is this container is able to send HTTP post to Proton directly, just like how you send it to Kafka. And the Proton is able to receive all the real-time data and accumulate in our streaming storage. Then we can share this back to our historical part. So maybe I can show you.
So then the way I would use it is, instead of using Kafka to send my data, Kafka stream, I would send it to Proton, right?
Yes. So this is our architectural diagram in a simplified way. That is, we have. Let me make this bigger. So we have our streaming storage, read a head log, and also historical storage based on the code of ClickHouse. So these two are provided within Proton altogether as a single binary written in ClickHouse. And we provide REST API for you to ingest new data or run the query. And all the data will be captured as a concept of streams. It can be append only or more advanced like changelog or version. And you can create a materialized view to either cache the data or provide some running job. And we use external stream to read from Kafka or write to the Kafka. Even we can do the similar thing for the logs. We can read from log or write to the logs. And for Proton, we provide this unified storage and unified processing, and also all those other components. Yeah.
Yeah, this is really impressive.
Yeah. So hopefully you will see other interesting stuff. So moving next, I'm going to show you some interesting and so in the previous demo, I show you how to using car level data, right? So it's the other Docker Compose. So to get started, you usually can have other opportunity. For example, you can create a random stream just to generate data in the memory. So for example, this is lab data. So by the way, this is Debezium, so we also support that. So for example, we now create live data, and if I go back to my terminal, so this is a random stream. Like we generate a lot of random key and values. As you can see now, we are making sure this is now we are processing 14 million rows every second. 14 million rows. That's a lot of data, right? So we easily process 14 gigabytes. So this is demonstrates how amazing Proton it is. We really focusing on performance a lot, and we even support.
I think, yeah, I saw it in a diagram. You wrote it in C++.
Yeah, super fast. We can access a lot of latest OS capability. For example, IOU ring, those are low-level stuff, which is not usually available for JVM. And we also based on ClickHouse as the very efficient data storage and they have very solid engineering, but we also build our own stream storage and unified processor. And there's also other, I may not have time to demo everything, but for example, if I do some aggregations, right? So aggregation also require a lot of memories and processing power. So similarly, that is, we can get, this is 25 million rows to aggregate data easily. And if you create a new stream with a lot of keys, so this we call high cardinality problems. Right. So in this case, we can efficiently process it. So the context of that is, if you are running your IoT use case or fintech use cases, sometimes the goodbye key, the key is have a lot of data. So for example, in this case, I think there's a million unique keys. So to goodbye data, you can naturally think that is, you have to have multiple kind of temporary storage for every key. You have to accumulate the data. So it's really a very good test to see how you can optimize your system to support such a high cardinality. So we support this very well. And the other thing I want to demonstrate, just actually using my phone, is I'm using a mobile app called Sensor app. I will share the link later. And the interesting thing that is, I built a dashboard. And I just press the button. So I'm rotating my phone. And when I'm rotating the phone, you can see all these three charts shows differently. I mean, there are some issues for this XYZ chart. So you can see this a little bit, but it will reset. But anyway, for the other two charts, you can see if I shake the phone, the data is changed. If I put this still, right? So it's different. So how things work, that is, go back to this one. So how things work, that is, awesome sensor is interesting. Awesome sensor logger. So this is also open source project. You can install on your iPhone or Android, and essentially it leverage all the sensor on your phone, for example, XYZ or the rotation, and you can push data out. And what I did, that is, because Proton, as I mentioned, that is, Proton also support HTTP post injection, so I can easily push the data to Proton, and we can leverage dashboards such as Grafana to visualize them. All right, so this is also the other interesting demo. And I think the last demo I'm going to show is about the CDC, because you ask why there's the stack of Rapanda in the list. So go back to this one. So proxy is the container I'm used to process the data from the sensor to Proton using Proton's expected stuff. And everything here is for our last demo, which is a CDC. So as you are right, that is, Rapanda is speak to the Kafka API. So it's we like Rapanda because it's also written in C++. It's very efficient, and also they provide very nice UI, the console. And we're using Debezium as a system to do the CDC, the capture data, change data capture, to sync data coming from MySQL and send them to the Rapanda server. So if I go to Rapanda UI, so which is this one, I make it bigger. So as you can see, that is, I already have this step studied. So there are some internal topics, and there's no connector. All right, so let me start the job. So it's here. So so this C URL is just simply to create a new job to sync data coming from MySQL. And if I run this and go back to the connector, as you can see, this is already there. And if I go back to topics, you can see, for example, there's a lot of new topics created. The customer.
Exactly. Is it like all the updates coming from the MySQL database, right?
Yes. So if I go back to the Debezium, so for example, if I select everything from customer, you can see that there are four rows in MySQL. MySQL, you can consider this as a OLTP, right? So it's transaction database, but it is really anti-pattern for you to run a lot of analytical query on OLTP, no matter it's MySQL or Postgres, because all the OLTP workload is designed for fast insert or transactional, but it's not designed for like a massive read. If you have a lot of reports or dashboard to run on MySQL, this will slow down your transaction part. So that's the reason why we have the OLTP part and OLAP part. And the Debezium or the CTC is really to efficiently sync all the changes from one database, one OLTP to the OLAP. So in this case, there are 3 rows, and we get 3 events from Debezium put into the Kafka or Rapanda. They are in this R. R is read, so there are 3 initial rows. And if I set this in Proton, so I think I can simply run everything. Yeah.
And what are you doing now? Is it like
Yeah. So what I'm doing that is to inform Proton to read. For example, we create an external stream as a Kafka type to read from this Kafka, and using this topic. Topic is the for changelog of customers. Then I create a changelog stream, which is a more advanced mode of stream. We have the primary key, and then we have a bunch of processing for the data. So as you can see, this is actually a complex JSON. This also demonstrates how powerful Proton is to process JSON in an easy way. So for example, like every read, you will have the new data in the after side. And if you delete or update, you have different format. So let's go to the demo. So say if I select a star from customer, as you can see, all the 4 data is synced to here. Live data, I will hopefully when I make any changes, you will see new events. So let's insert a new row. Say after this, so 1005 Jove. You can see this is happened immediately. So I'm querying Proton, but I just made a change to my MySQL, adding a new row. Right. So if you query MySQL, so there are 5 rows, but the moment I change, this data is already synced from MySQL to Rapanda using Debezium, and also in the same time, Proton is able to capture that changes and extract the value from the JSON and put into our storage. And what is more interesting that is this is update, or this is insert, which is actually it's not very hard, right? So there's a lot of systems support such append only. But what really stand out for Proton, that is, we can support update and delete. Actually, these are also different levels. So update, people sometimes call this upsert because you update the same key but with different value. So like, imagine you change this first name to change it. Actually, this is the name on my passport. Jove is not my, this Jove is just my nickname. So if I run this, and where is it? Okay, cool. So if I run this, you will see that is I get events. Jove is delta is -1, change is 1, meaning that is I cancel or delete the previous event and add a new event called change. Right, then in that case, if you run this again, you will see the name is already changed. And as I mentioned, that is at the very beginning, we support both streaming mode and resolver mode. So if you are integrating Proton with your system, you can just run as a regular kind of historical mode. Then, so this is change and this name is already changed. And you can even do the update or delete. So how about we delete this message? And if you run again, this is gone. So you can see the value that is, you can build a very powerful analytics in the real time without slow down your MySQL, because you can do all the insert update in MySQL, and all the analytics workload is never happened on the MySQL. It's leveraging CDC technology like Debezium, sent to Kafka, and eventually arrive on Proton. And the Proton can support, as I mentioned, that is 20 million rows a second, right? So you have a very good balance. That is, you can run a real-time or historical analysis in Proton without slow down your OLTP system. Yeah.
And I imagine that like if you keep generating data for months and months and months, eventually for you doing these aggregates become difficult, right? Do you have some sort of like, how do you call it, retention mechanism when you delete the old data or move the old data to some sort of cold storage?
Yeah. That's a very good question. So so if we go to our documentation, so we do support the retention policy, right? So as I mentioned, that we have both the historical storage and the streaming storage. So for the streaming storage, you can set how many data I want to keep. Do you want to keep 1 GB or 10 GB, or every data in the streaming storage, how long this will consider as necessary to store? You can retire from streaming storage. And for the historical storage, you don't really have the chance to retention by size, because it will be very expensive. For example, like you mentioned that is you have a lot of data, then to calculate the accurate size on the historical side, it will be more expensive. So we only support time-based retention. So after 12 hours or after 12 months, you can remove them. So if you don't set the retention policy, it's as good as ClickHouse or many other OLAP. You accumulate all the data here in Proton. But if you more care about your recent data, yeah.
Yeah, cool. So you don't need to do anything out of the box. You get the best performance because the data from the streaming storage is moved to ClickHouse, and when you do all these aggregates, actually, like most of the work is happening in ClickHouse, which is very good at aggregating, right?
Yeah,
like if
exactly.
you have a ton of historical data, I mean.
Yeah. And we also support tier storage. That is, the streaming storage and the historical storage naturally is on the same server, like SSD or EBS. But if you really care about, I want to keep all the data, but I don't want to pay the fee of SSD, you can configure our system to send data to S3 in a cheaper storage. And we can if we don't have that data in the local kind of cache, we can load them from the S3 or other blob storage, object storage.
You mentioned that you made it open source 3 months ago, but I imagine this is not what you wrote in these 3 months. So it looks like you put a lot of effort in this, so it's like it's an immense amount of work. So how old actually is Proton?
Yeah. So we actually we worked for 2 years already, right?
Years.
We really at the very beginning we really want to move very fast. So we feel like if we open everything, it's good, but we might not have enough time to take care of the community, and also we might make some mistake for sure, right? And we might change our API, our behavior, and we start from our cloud service actually. In March 2023, 2022, we have our first cloud offering. That is our feedback. So actually, after this 18 months effort, we open source it. And in the same time, as I mentioned, that is we actually really leverage ClickHouse as the solid OLAP foundation. But ClickHouse is not really focused a lot on the streaming today. So we add a lot of feature on that. And also we actually send some PR to them. So if you or your audience is familiar with ClickHouse, they also have the capability to read from Kafka. They call Kafka engine, but you have to put them in a local view, stuff like that. So we are introducing those what I mentioned that is at the very beginning, those select counter star from the table. We introduce those streaming application to ClickHouse, and the PR is being reviewed. So we want to work together with ClickHouse to make things easier, right? Because it's really a choice. You can set up a JVM, you can set up a cluster, but if you just get started, if you really want to build some ideas, hopefully system like Proton can give you a very easy to get started. Yeah.
Do you accept contributions right now?
Yeah, of course. So it's Apache 2, right? So everyone is welcome to send us PR, no matter as little as like README or a builder enhancement, or if you really like high performance C++ development, feel free to check our ticket. So actually, we have all our sprint planning and the tickets and issues, all our GitHub, and you feel free to pick up some. And there's a lot of room we can improve. For example, our current build process may take almost 2 hours because building, there's a lot of components. So how to reduce the time of CI, how to add more unit tests, how to add other advanced features. So that's all we are looking for. And all you need is to pick up some ticket and some, I think there's a CLA, contributor agreement. So it's a fairly straightforward process. And we made this Apache v2 license so that you can even modify it, even host it by yourself. So we really want to make this as transparent as possible.
Yeah. And last question. Do you have any advice to anyone who is watching this?
Yes. So as I mentioned, that is the industrial has been focused a lot on the OLAP, on the data warehouse a lot. And if you want to build a real-time processing using Kafka, using Flink, there's more and more tools available. But with Proton, you get really a very unique opportunity to process both real-time data and historical data in a very simple way, as simple as a single binary. You can download as a binary, you can use in Docker, you can use it using Homebrew, and you can leverage all your existing skills such as Grafana or Metabase to build the entire data stack. But you don't have to worry too much regarding two different stacks using Lambda or have a lot of effort to coding by yourself. So this is really a very, to me, it's a very interesting attempt. And we already have a lot of customers, even some high-end customer on the fintech area doing algorithm-based trading using us. But in the same time, Proton is designed to be very fast and simple. So feel free to check our repo and get started and join our Slack for more discussions. I'll just give us a star if you want. Yeah.
Yes, that is what I was going to say. Stars, yeah, please give them a star because it's an amazing project. And thanks a lot for making it open source. And thanks a lot for the demo.
Thank you, Alistair, for inviting me. I'm so glad to join this community.
Yeah, thanks. So, see you.